Hi everyone, Mrs. Keener here, and we're going to do the Unit 2 notes, but here's your meme for this video. Brace yourself, factoring is coming. Any Game of Thrones fans? I just watched the first episode, so I'm excited. We're on this page of notes, and I'm going to walk you through the words. You can pause and copy and then listen, because there's a ton of examples on the bottom and the back that I want to do with you. Okay, ready? Some vocabulary. So you're going to copy this down or pause to copy it down. A factor is any term that's being multiplied. If it's next to a plus or minus sign, it's not a factor. A quadratic expression is a polynomial of degree 2. So it has an x squared and it doesn't have anything bigger than that. So it can't have an x to the power of 3 or to the power of 4. It has an x squared and that's the highest one. We all need to know what standard form is, and that's in decreasing exponent order. So we're always going to have the x cubed, that's not a quadratic, then x squared, then x, and then the constant. The number on the end is the constant. Okay. A leading negative, you might not know this. So if you have a negative in the front, like a line leader, see how that negative's in the front? We're always going to factor out a leading negative. Okay, let's get to some examples. So you should be familiar with factoring out the greatest common factor. I should have been doing it for a few years now. So you say, what goes into both of these? Well, we know a 6 goes into 12 and 6, so that comes out. And then there is one x in both of them. This one has 2, and this one has 1, so we can factor out 1. And when we factor out 6x, then we say what times 6x would give us back 12x squared. 6x times 2x is 12x squared. 6x times negative 1 is negative 6x. And so we are checking this by doing multiply, which was the first set of notes. Here, do you see how we should not factor this? So you might have factored this in your previous math classes as is, but we're going to write it in standard form first. Not the answer, but you start with the question. See how I moved the negative 10x squared plus 5x? And then I factored out the greatest common factor, and do you see it had a negative to start, so I factored that out, but then the negative times this negative would give us back the positive. Okay, this was in standard form, and the only thing in common was an x, so I factored that x out. I thought I had to keep going, but we were done. So that's greatest common factor. This is review. We're going to learn lots of new factoring, so we need to get through the review quickly. This is also review, difference of two squares. Anytime you have two squares, perfect squares, with a minus sign in between, they factor to a plus b, a minus b. And so here are our first 3 steps to easy factoring. Write in standard form, take out the greatest common factor, and then see if it fits this pattern. So we're going to do some examples using these 3 steps. Ready? Is this in standard form? Yes. Is there a greatest common factor? Yes. What's in both terms? A 2? Is there an x in both of them? Nope, just a 2. 2 times what is 2x squared? 2 times what is negative 8? Okay, now that I factored out the greatest common factor, look to see check if difference of two squares. Is x squared minus 4 a difference of two squares? It is. So we're going to factor it like the formula says right there. X plus 2, x minus 2. That's it. Is this in standard form? Nope. So we're going to rewrite it in standard form. What's the greatest common factor? A 2, but is there a leading negative? Do you see that leading negative? Yep. So we're going to factor out a negative 2. Okay, ready? Negative 2 times what is negative 50? Negative 2 times 25. Oh yeah, how come we didn't take out an x? Was there an x in both terms? No, there was not. So we still have an x squared here. Okay, negative 2 times what is 2? Negative 2 times negative 1 would give us back positive 2. Do we have a difference of two squares here? We do. How do I know? You could take the square root of each one. So what's the square root of 25x squared? And the square root of 1? Like that. Is this in standard form? Nope. Rewrite in standard form. Common factor? What's the common factor? Greatest common factor, 8 and 18. Let me think. 2? Is it just 2? 4 does not, and 8's not. So 2. And is there an x in both of them? Yes. So we're going to factor out negative 2x. Okay. Negative 2x times what is negative x 18x squared? Negative 2x times 9. 9x. X times x is x squared. Okay. Negative 2x times what would give us back 8x? Negative times a negative would be a positive, and There. Okay, they're trying to trick us, those evil math lords. 9 is a perfect square and 4 is a perfect square, but is this a difference of two squares? Is the x a square? No, it is not. So you see here how we had 25x squared, and we could do x times x is x squared, but there's no x squared here, so we are actually done. See, check if it's a difference of two squares. This is not, so we have to stop here, whereas this one was, and we kept going. This one had the square, this one did not. Greatest common factor? Do we have a difference of two squares? Yes. Square root of 4x squared, so 2x times 2x would give us 4x squared, and 1 times 1 would give us negative 1, plus and minus, and that's it. Standard form. Greatest common factor, 15x. Is there an x in both of them? Negative 15x, okay. Let's see here, 4 plus negative 1. Okay, we wrote it in standard form. We took out the greatest common factor. Is this a difference of two squares? No. Why not? What's the difference between this and this? This one had the square, so we are allowed to factor again. This one does not, so we're done. Negative 9. Is this a difference of two squares? Yes, it is. Square root of each one, plus and minus. Good times. That should all be reviewed. That should be easy. Ready? That's funny. That is wrong. Let's see. Nope. Answers. Nope. Look at me. Look how Okay, are you ready? Factoring quadratic expressions with three terms. Do you know what a quadratic expression with three terms is? It's called a quadratic trinomial, right? We should just call it that. Are you ready? Standard form, greatest common factor, and then I'm so excited. Is this in standard form? Yes. Is there a greatest common factor? No. Here we go. We're going to use something called the guess and check method. We know that 2x times x is 2x squared. And we know what multiplies to get 10. 10 could be 1 times 10 or 2 times 5. So we're going to try 2 times 5. 2 times 5. And then we're going to check it. And this is why we use pencil. I usually use pen on the videos, but you should be using pencil. Okay, ready? 2 times 5. Oh, they're the same. They're both negative. 2 times 5 is negative 10x. And then these two terms have to add up to get negative 9. Do they add up to get negative 9? Nope. So we're going to try something else. We're going to try switching the 2 and the 5. Ready? Check. 2x times negative 2. My lights. I did that. The lights went off and I have a wrong thing here. Let's see here. I think I'm going to keep it. Okay. My apologies. Negative 5 and negative 4, do these add up to get negative 9? They do. So guess what? We got it. Yeah, but how many guesses do you have to take? You just, you got to keep going. What multiplies to get 6x squared? 3 times 2? Okay, what multiplies to get 2? 2 times 1. Okay, it's going to multiply to get a negative 2, so they're going to be different signs, and I don't know what they are. I just made those up. Ready to check? Here we go. 3 times 1 is 3. Negative times 2 times positive 2 is negative 4. Do these add up to get positive 1? No, but we're close. How can we make it correct? Keep the numbers, change the signs. Check. Positive 4x, negative 3x. Do those add up to get the 1 in the middle? We're done. How do you know you did it right? We are foiling in our head. We're doing first, outer, inner, last in our head. And we got it. Here we go. What multiplies to get 4x squared? 2x times 2x, so those go in the front. What multiplies to get 6? 2 times 3? I'm just guessing. How do I know where to put them? I don't. I'm guessing. And now I'm going to check. Outer, what would that be? 6x. Inner, negative 4. Do those add up to get negative 5? No, not really close. So I'm gonna switch them. Switch the 2 and the 3. Okay, outer, inner, not even close again. Oh, I need different signs. I need like a positive there. Not even close again. So what should we do? Well, what else multiplies to get 6? Not just 2 and 3, but 1 times 6. 2x times 2x. Okay. Let's see here. Oh, it doesn't matter because the 2 and the 2 are in the same spot. So we got the same answers here and here. Okay. 2 times 6 is 12, and 1 times 2 is 2. Can I get 5 from a 12 and a 2? No. Is this where we give up and we start crying and whining and going, oh my gosh, I hate factoring, I can't do this? No. We're missing something. Do you see how we're having 2 times 2 is 4? What's another way you could get 4? What's another way? What happens when you run out of room? You make room. Okay, we make room. Let's try 4x times x. And then what multiplies to get 6? 2 and 3. All right, let's do 4 times 2 and 3 times x. So 4 times 2 is 8 and 3 times x is 3. Can those get us a negative 5? Yeah, how? How can it be negative 5? If the 8 is negative, which means the 8 came from here, and the 3 has to be positive, and the 3 came from here. Okay, look at this mess. What's your final answer? This is the final answer. There. How do you know? Because this, if you were to FOIL this, it would equal this. Guess what? We're going to keep going. The more you see, the better. Oh, 4x squared. Should I try 4x and x, or should I go with 2 and 2 again? I don't know. Let's try 4x and x. It did us good last time. Okay, what multiplies to get 5? Oh, watch. I'm going to teach you a shortcut now. Ready? How can this be easier? We know 5 is 5 times 1. You agree? 4 times 5 would give us 20. Do I need 20 if I'm trying to get to 12? Nope. 4 times 1, so I'm not going to put the 5 there. Do you see how I just did a guess? Is this correct? See how fast we're getting? Can that be right? No. So it can't be 4. It has to be 2 and 2. Okay. It didn't matter where the 5 and 1 went because those were both 2. And they're all positive. I don't see us getting a different answer, so let's check this one. 2x. Look at that. That was easy, see? Not all are hard. This one's not in standard form, so we're going to put it in standard form. Here we go. What multiplies to get 3x squared? 3 times 1. And what multiplies to get 6? 1 times 6, or 2 times 3. Let's see here. Watch this. You could also do this. Does 1 and 6 work? 3 times 6 is 18, and 1. Does that give us 11? No. What if I switched 1 and 6? Would that work? 3 and 6, does that give us 11? No. So what do we want to try? 2 and 3. So we're going to try 2 and 3. 3 times 3 is 9, and 2. Do 9 and 2 give us 11? Yeah, if they're both negative, let's check it. Negative 9x and negative 2x. We did it. And it was a lot less messy, right? What do we do first? Write it in standard form. Here we go. Multiplies to get 5x, multiplies to get 2. If I put the 2 over here, what number would I get? I would get 5 times 2, which is 10. So I don't want a 10. I need a 3. So I'm going to put the 2 there and the 1 there. 5 times 1 is 5 minus 2 equals 3. See how we do some steps in our head? I know I'm going fast. I'm almost out of time. I'm going to pause it to fill in the rest, and you're going to write them down, okay? This one I got on my first guess because 2 times 3 is 6, and negative 1, that would give us negative 7. This one we had to write in order, but then we had to factor out the greatest common factor and then factor the trinomial. So this is the final answer. What do we do with the negative 2? You leave it there. And then this one was like a joke. It was so easy. All right, good luck. You're now ready to do the second practice on lined paper.